when I was in school, I remember it, there were people who spend like 20 hours on their programming assignments and get a 0 on it. Like, you just gave up like half your week doing something and you got nothing because you technically had something that didn't work. And that was pretty kind of a demoralizing thing, right? All right, so let's talk about the final exam first. So here, I'll put it in the So final exam will be 10 questions, all short answer / essay / coding. So no true false, no multiple choice, none of that crap. Each question will be worth 10 points. The exam I'll design to take about an hour. I would say it's probably going to be a similar length exam to the midterm. I'll probably put like 2.5 hours on the time limit. It'll be up by Monday morning. You just need to complete it sometime during the week. So make sure you set aside, say, 2.5 hours just in case you want to use the whole time period. I doubt it will take you that long, but just make sure you've done that. You have to do it in a single sitting. Get it in by midnight Friday so you can decide when it best fits your schedule or when you want to study for it relative to your other finals. Closed book, closed note. You can use your calculator if you want. Do me a favor, don't work in groups. Hopefully you all see that I'm a pretty friendly grader, so I want to see what you've learned. So as we continue through your 4 years, we can see how you've improved during your 4 years, because ultimately all of our goal is if we dump you out at the end and you go get jobs and you're good at what you do, regardless of how good you are today. So do everyone a favor and don't get help on the final. Let's see what you've learned during the class and we can operate off of that. Yeah, so that's the scoop for the final. There will always be one conversion question in all my tests. So either convert some base to some other base or possibly convert some size to some other size. Like I might say, 221,000 kilobits is how many gigabytes or something like that. So it'll be from one of those two sides of things. I would say I tend to do more number conversion stuff than the other one, but they're both fair game. And that's true in every single one of my classes. But usually on an exam like this, there'll probably be one question like that. So hopefully that's free points. Let's see. So what I want to do is I want to go through our slides. And so this is what I'm going to do when I write the exam. And actually what I did the other day, and I actually have some time after class today, I might do it today too, is right after I did this for my 450 class, I went and wrote the exam. So what I just say here in class is pretty fresh in my mind. So I flip through the slides and I write the questions, basically doing what I'm doing right now, saying which concepts do I think are important, which concepts are less important, so you kind of know where to focus your studying. All right. I would say a majority of the exam is going to come from the second 8 weeks, but there will be some stuff from the first 8 weeks as well. You should be able to, there'll be at least 2 or 3 programming questions where I say, write a method that takes something as a parameter and does something with it and prints a result or returns a result, something like that. So make sure you can show me you understand the difference between displaying an answer versus returning an answer. That functions can take a value and do something to it and actually spit the answer out as opposed to printing the answer out. Those mean different things. There will probably be something on the exam that talks about like the static versus non-static stuff. Really important. I mean, we've seen it in the documentation for Unity. So kind of the proof is in the pudding. We learned about it with Java. Then when we started looking at some of the stuff in the Unity documentation, it told us how to call it, right? If it was static and it was from vector 3, we say vector 3 dot something. If it wasn't that, we did, you know, we would have to have an instance of like a rigid body or something like that in order to call one of its methods. All right, so definitely know about class methods versus instance methods from the perspective of defining them and also from the perspective of writing them. So if you were to write a class method, it has to have static in front of it. If you were to call a class method, that is, if you see a method in the documentation that has static in front of it, you call it using the name of the class in which the method was defined. If you are writing an instance method or a non-static method, you would not put the static keyword in front of it. If you were calling a non-static method or an instance method, you would use an instance of the class in which the method was defined to call it. Okay, so that last, whatever, I spent 45 seconds saying that stuff, that was literally the answer to the, I think it was the very last question on the midterm. If I remember correctly, that question was missed way more than it should have been, especially as much as we harped on that concept. I would be extremely surprised if that question, potentially the identical question, doesn't make it onto the final. And if it gets missed at that level again, I might throw things. And then it puts me in a bad mood when I'm grading. Maybe I'll grade that one first because that'll set the tone for grading the whole rest of the exams. It'd be bad. Definitely know that concept. It will be on the exam. I'll never ask you about sizes of these different things. You should certainly be, you know, able to use ints and chars and doubles and booleans. You won't have to differentiate between bytes and shorts and things like that. Those get hit in some other classes, but you don't have to worry about that in here. You have your integer types, you have your character types, and you have your floating point types. And you got your Boolean stuff. I like to ask questions about string manipulation. It tends to be a hobby of mine. So I would say the programming questions on the exams will probably lean heavy on take a string as a parameter and do something to it, or take an array as a parameter and do something to it, or take an array list as a parameter and do something to it, something like that. I like messing with collections. Those tend to be the easiest kinds of questions to like write little puzzle questions to kind of see where your programming competence is now. Because it's certainly hard on an exam. I can't give you something that's like of the size that you're doing for your homework assignments, right? Obviously. So it needs to be these little puzzle methods and things like that. But I do like manipulating collections. So I would definitely make sure you remind yourself how strings work and arrays work, and array lists. Char at index of, a lot of those manipulation ones, I kind of like using those guys. So you might review those, what char at does and what index of does and how you might use that. Remember, index of returns the position, the first occurrence in a string where a character appears, or a -1 if it's not there. And that -1 part's pretty important. Understand this concept of when we're comparing strings to each other, the double equal sign is not what we use. We use the dot equals method for comparing strings. Dot equals compares the contents of the string. Double equal sign is our primitive equivalence operator. So we use that. And if you compare strings that way, it's not going to give you an error. What it's doing is it's saying, are these two pointers? Is this the same string in memory? Does it live at the same place? Okay, so that's where it can be a little confusing because sometimes you'll get the answer you expected if you always use string literals. But if you created different instances of strings completely, double equal sign will not be true for two strings that happen to hold the same string, but live in different places of memory. So understand that concept. It'll probably be on the exam in one form or another. You have to compare strings, or I might even ask you directly to explain this. Go ahead. Yeah, I don't care. You can pick your language on an exam, since I'm expecting that you're not using a compiler and you're writing it by hand. I'm looking for C/Java-ish code. I'm not going to take off points if you miss a semicolon or if you use a capital E versus a lowercase e, something like that. Yeah, as long as it pretty much shows me, I mean, like I think I said before the midterm, it's usually pretty clear whether someone generally knows what they're doing or doesn't have any clue what they're doing. So make sure whatever code you give me shows that, hey, you have a clue what's going on, and don't worry too much about the syntax. You know, if you said like dot is equal to or something like that, that would be fine. You know, what if you threw a bunch of weird symbols or just like made up a function that says like answer to number 4? And this is a one-liner. All right. So really that thing I just talked about is this slide and this slide, where we talked about literal memory space versus creating a physical new string, like this string right here, where we actually requested new memory. So S3, when compared using the double equal sign, is not true to being equal to S2, because these guys are in different memory locations. But S3 dot equals S2 is true, because their contents are the same. All right, so make sure you understand that. And that's something that crosses over into C#. It's something that crosses over into a lot of languages. Unfortunately, I guess I believe it's unfortunate, some of our newer languages have overloaded the double equal sign to allow you to do string comparisons, where the double equal sign does look at contents, but then that has now removed your ability to say, do these two strings live in the same place in memory? That's no longer a feature of that language, because they chose to take that double equal sign and make it mean what you probably wanted it to mean, but you might not have. So you've lost that ability. Here's that static versus non-static stuff. This will be on the exam in one form or another. Polymorphism, that could find its way on there one way or another. Maybe a throwaway question, lower priority, but that's a word I like. Definitely be able to write an object. So if I say create an object that, you know, represents, I don't know, a person, where a person has a first name, a last name, and an age or something like that, be able to create the fields. I say write an appropriate constructor, be able to write all those things so you can show me that you can create an object that represents stuff. We've been doing that a bunch with players and rooms and exits and all that stuff. These are all things you should be able to roll with. Definitely be able to work with arrays. Know that arrays are represented in contiguous memory. That whole concept is probably a more important concept in the next course, 300, where we start writing our own linear linked data structures that are not in contiguous memory. So that gives us that comparison. So I don't know if I would be able to ask a very good question on an exam about arrays being in contiguous memory, other than why are they fast? But at the very least, be able to use arrays, because I tend to like to put those into the programming questions. Remember, the generics are what we did with the array lists, where you have the little angle brackets, and we've seen it on the C# side too, where we say like get component, we want the rigid body. We use the generics to say this is the kind of animal I want. Instance of operator. That looks like it might be a fun one for a little programming question, maybe going through in a you know, a array of top level objects, abstract classes or something, where there are two different types. Maybe it's cars and trucks, and you have to count the number of cars versus count the number of trucks. So using the instance of Boolean operator allows you to say, is this guy an instance of one of these types of classes? That would be a handy thing. Exception handling will probably not be on the exam. Definitely be aware of it, but we mess with that a lot more in some of the other classes like systems programming and stuff. And this is what I was just saying as an example. Let's say I say that you have an array of inhabitants, and I want you to go through that array and count the number of players and count the number of monsters that were in that array. You should be able to use the instance of operator to differentiate the thing that lived at bucket 4. Was that a player or was that a monster? And increment the right counter from that. So be able to work with whether this is an abstract class or just the generic parent class of these two dudes. Know that if you have a collection of one of these, it can come in the form of either of these. A player is an inhabitant. A monster is an inhabitant. So inheritance would be fair game. Again, if I'm asking you to write something dealing with inheritance, it would probably be fairly simple. That way you're not writing 4 pages of code for one exam question. But it would be fair game in one form or another. Know the difference between the this and the super keywords. Know what the abstract keyword does. Means that an abstract class is a class that you cannot create an instance of. It's how you can flag a class to say its use is to be used for inheritance. And I don't intend, for instance, we don't intend to ever see generic inhabitants walking around. We expect to see players and monsters, but this inhabitant thing only exists to act as a base for these two guys. So you would make this an abstract class so nobody accidentally creates this generic blob. Probably won't ask about interfaces. They are important, but we don't practice with them enough in here to give you a good context for them. Threads will be on there one way or another. This was kind of our bridging point. We dealt with threads right before midterms. We wrote our own threads in here with Java, and then we've seen multi-threading over in Unity through that update method, right? Every single script you have, every frame, that update method's getting called, and all those guys are sort of kind of happening at the same time. And we've even experienced that timing issue where, okay, which of these dudes happens first? And do we have to make sure that maybe we put it in the awake or something before it happens an update in case this guy's reliant on something that happens here, but it hasn't happened yet? Something along those lines. So know about threading. I doubt I'd ask you to write your own thread, even though it's not incredibly difficult, but I might describe a programming question and say, assuming you have a thread that's supposed to do something, write the run method for that thread to accomplish that task. So what the contents of that thread would be, that would be maybe how it would show up. So we start getting into Unity, kind of know what Unity is as a tool. I mean, it's effectively a code editor. And really the focus is when we get into Unity is we start talking about design patterns. So definitely know about the MVC, design pattern model view controller, and be able to talk about how Unity specifically handles this, specifically the view and the controller part. So our view is the pictures that we see inside the Unity editor. The controllers are scripts, and we have ways of exposing things from our scripts to the editor, and we have ways of the editor telling values to the scripts and associating the scripts with them. Definitely know that game object is kind of our top level thing. It's our version of a generic object in Unity. Be able to work with, be able to know that a transform is a collection of position, rotation, and scale. For us, we mostly care about position, but effectively know that it's an XYZ coordinate. So if I talk about things like vector 3s in some question, I'm asking you about an XYZ coordinate. All right. I'm not going to have you do stupid math and stuff like that with vectors, because that's one of those things that you eventually through experience figure out how to do, but otherwise you just kind of mess with it in Unity until the thing on the screen starts doing what you want it to do. But if I reference a vector 3, you should know that's an XYZ little little package thing. So know what a generic design pattern is. So it's that idea of a proposed good solution to a common problem, where what's a common problem? It depends on the person. We talked about MVC, so definitely an important one. Also know about singletons. Both of those will find their way in the exam one way or another, the design patterns. I could ask a scenario type question with Unity where maybe I tell you about, like, there's two game objects that need to do something related to each other. How might you set that up? So with the expectation, you might say, oh, well, you'll put a box collider on both of them. And then in your script on collision enter, you would set something in the singleton, something like that. Those are things that you're not going to really be able to write on. I'm not going to ask you to write Unity related C# code on the exam. I suppose if I gave you some code that maybe, you know, extracted the rigid body from a game object or something like that, and I set its velocity to something or whatever, and I asked you, what does this code do? That would be fair game. But I might ask you at the high level, how might you go about solving this problem? Give me a, you know, and that almost is similar to like what we talked about last class with the tunnel thing, where we wrote it the first time, we saw the problem with the race condition with the two triggers, and then we just created a different spawn point that was on the inside. So, you know, that's kind of a clever workaround to a problem. You could probably come up with a couple other ways of handling that. You could disable the other trigger right before this guy comes through and then re-enable it, something like that. But, you know, come up with maybe a clever solution to something, but more in words than in code. If I said, how might you handle this? So questions about the exam? I will probably not ask you any sort of specific questions about, like, you know, rigid body methods and things like that. It'll be more at the high level. This course is more about problem solving with programming. It's not about Unity. We just happen to do some interesting problem solving using Unity that gives us more visual feedback. Historically, we've done Android programming in here instead of Unity. I feel like Unity was probably more fun. I promise you that Android Studio can be every bit as frustrating as Unity. So it's not like you got thrown into some, pit, and like, it would have been so much easier on the other side. I also think debugging in Unity is more fun. So it just kind of is what it is. But the focus on the exam is not going to be, tell me about your, proficiency with Unity, as much as it is, show me that you have become a better programmer than you were since the midterm and since you were since 200. Same policy as usual. If you do better on the final than you did on the midterm, I'll replace whatever grade you got on the midterm with your final exam grade. So if you bomb the midterm with a 10% and you get a 90 on the final, that 10% becomes a 90. All right. Because at the end of the day, I just have to give you a grade based on how well you've mastered the material, because you're going to get dumped into the next class, which is data structures. And that class is not going to be using tools like Unity, more than likely. I don't know, I'll talk with Blade over the summer and see if we can find a fun thing to do. I usually teach that class, but he's teaching it for the first time in the fall. I taught him how to program. I promise you he can do it. And we're going to keep working on the language skills and stuff. So hopefully you've seen some improvement since midterm. But we'll try to come up with a good solution for that. But it's a neat class, but it's more focused on pointers and things like that. So I guess have fun with that. All right. Questions on the exam? Make reasonable sense? No real surprises? Okay. So let's just look at what we were supposed to do for today and see what we have time for, or if we have time for it. All right, so have our power pellets. So if when we eat a pellet, which we did last time, right? Guy eats a pellet, we want there to be some kind of mode, maybe with a timer or something like that. And when we're in that mode, ghosts can then be eaten. And maybe it's a two-way street. So like, you know, right now, even though our ghosts are kind of idiotic, and I don't remember, did you send me that thing just to me, or did you post it on the 250 channel, how the ghosts work?
I just sent it to you.
Okay. Yeah, he had found I think it was a YouTube video that I haven't watched through the whole thing yet, but I clicked it on for a second. But the how the ghosts were actually originally implemented in Pac-Man, just to give us an idea. So it actually is kind of interesting because, you know, when you play the original Pac-Man, if you're not somebody who plays all the time, you know, you haven't memorized the patterns of those different ghosts. So the ghosts probably feel fairly random to you, right? Well, we're seeing in here, you know, we're using what we would call like newfangled stuff with the AI attached to our ghosts, where our ghosts really seem idiotic, right? Like, you know, it's not that hard to you know, stay away from using, you know, young people hand-eye coordination. I'm a little sketch, but I just have to build in. I have to make my chomp able to fly like the other game, go across the map. It is interesting that you and Unity is great where you can visualize how that AI is actually working, that decision making of the ghost, where it's deciding what's my most efficient path from where I am right now to the vector 3 I'm trying to get to, or the game object I'm trying to get to. And you can see that ghost behave in very strange ways, right? Get him stuck in corners, or he gets confused, he doesn't know how to get to you, or I think we're also probably seeing some bugs in their AI mechanism. I would say that if we kind of look at Unity's built-in AI, it's probably not really designed for this level of kind of maze traversal. It's probably more set up for maybe having, you know, having kind of an open map where maybe monsters kind of path around a certain area or something like that. Or maybe you have a series of kind of spawn points, like I don't know, milestones, where you maybe have I don't know, let's think about like a game like a World of Warcraft or something like that, where you have you know, a monster out in the middle of a field, and maybe he, you know, you want him to seem kind of alive. So you have like maybe 15 different game objects that you have invisibly set there, and you kind of randomly have him path to some of those different game objects. And, you know, when a player gets near, maybe he starts chasing that player. And after that fight, if the player runs away and they do it, he kind of returns back to one of those things and keeps pathing. But it's probably better for more open worldy type stuff to kind of add some life to your game instead of these precision turns. I think we're seeing in those precision turns, the AI, you know, really doesn't work all that great. You probably could program something in, kind of build your own halvesy type AI, where maybe when you collide with a wall, he rotates and keeps going forward in like a random direction that you didn't just come from, something like that. And that would allow him to, you know, kind of move around. So, you know, a ghost is coming across, he hits this wall, then so on collision, on trigger enter or something like that, he would pick you know, he can't go back this way, so he can only go down. So he would turn this way and then just go down until he hits something else, something like that. So you can kind of build in probably a sharper way of moving around with some randomness built into it. But it wouldn't necessarily always chase your Pac-Man dude. Okay, so what are some solutions on how did you go about putting your game into power pellet mode when, you know, collisions with the ghost would result in the ghost being able to be eaten or something like that? What were implementations of power pellet mode? How would you pull that off? Let's just talk about it. Go ahead. At the Singleton? or locally for Chompman. Okay. So you probably could do it a couple different ways. If Pac-Man knows about the pellet he just ate, he might be able to get that. Otherwise, I would think if Pac-Man eats a pellet and then, he flips a switch in his brain that says, now I'm chasing ghosts. So if I bump into a ghost right now, he dies, as opposed to if that switch is off and I bump into a ghost, I die. That would probably be a pretty easy way of doing it, and maybe just having an internal timer. I mean, you probably can do it based on the you wouldn't want to do it this way, but you could do it based on the number of frames. Just count up frames. Once you hit 2,500 frames, you just decide, okay, go back to the old mode or something like that. But then you have the issue if you have a faster graphics card. I think I used the example about an old arcade game, Dungeons and Dragons, that used to use busy. Did I mention this in class before? This Dungeons and Dragons example. Yeah, I got a faster computer, and for all their delays, they had used busy wait for loops. So as computers got faster, for loops ran faster. So when the game level first started, all the monsters came out all at once, where before it was much more natural timing. So if you get on some really fast graphics card and it's running at 600 frames a second, you're going to burn through 2,500 frames significantly faster than if it's running at 30 frames a second. So you probably would use some kind of timer and just say, this mode lasts for 10 seconds and then the switch flips back. So really at the end of the day, it just comes down to the collisions with the ghost and Pac-Man, and whether or not Pac-Man gets killed during a collision or Pac-Man eats the ghost during a collision, or the ghost gets killed during the collision. So shouldn't have been too bad. What method do we use for timer? I don't remember if we've actually looked at a is there a built-in timer class? I'm sure there is. Okay, so the class time has a current change in time, so you can since the last time you asked it. So when you say time.delta time, it gives you I'm guessing based on this code, the number of seconds since it, or number of whatever since it last happened. It's probably looks like a floating point, so it's probably seconds and milliseconds. So you could just keep subtracting from your target time until it's less than or equal to 0, and then you're done. So if you wanted that to be for 10 seconds, I'm guessing 10 seconds is probably milliseconds. So I bet you it's probably 1,000 is 10 seconds, or was it? This is 60 seconds. Okay, so it was based on a second. So yeah, so you just change this to a 10 and count it down. A lot of times timers are in milliseconds. So like, and you've probably seen this in some video games when you look at latency. If you start seeing, latency might be like 72 milliseconds, right? So 72 milliseconds is 0.072 turnaround time seconds. Pretty fast. But a lot of times, the first person shooter gamers who are really good, they want better than that. Like 72 milliseconds isn't good enough. They want like 15 milliseconds or better. But years ago, I mean, this would be pretty bad. This would probably tell you have internet connection problems. But there were people trying to play some of these online games using satellite-based internet, where you have much worse latency. So you had people who lived out in the boonies that could get, 5 megabit per second download, which might have been like as fast as anybody had download back then. But the latency was really slow. The time it took to request your download and then start getting it was slow. Once you were getting it, it was fine. So you could do like Netflix and things like that. But if you were trying to play a video game, you might have a latency of like 5,000 milliseconds, which means that when you did something 5 seconds later, everybody else became aware that you did it. So you were dead. If you died somewhere in that 5 seconds, you didn't find out about it until it was too late. So it's kind of an interesting thing. So you could have certainly done something like that. I bet you there's even a simpler timer in you could probably just set a somebody had to have created a timer class where you could just say, you know, do something in 10 seconds. I think they're in fact, I know that's in Unity. What's the name of the function? I think it starts with a C. Coroutine. Yeah, you can use a coroutine and say, do this in 10 seconds. Yeah. So really the default version of this coroutine is kind of their version of multi-threading. So when you say start coroutine, you're saying do something in its own thread separate to this. Here it is, coroutine with a time delay. So as soon as you have something happen, it looks like maybe this kind of thing at the end of it, you can just wait for some number of seconds with the 0.1. Can you also start the coroutine some period of time in the future? Yeah, it looks like you would effectively do a function that looks like this. And inside your function, you would start off by setting that Boolean to, you know, ghost eat mode or whatever, then wait for some number of seconds. And at the end, you could switch it back to the now ghost can kill us mode, something like that. So either one of those would have probably gotten it done. I don't know if coroutines are necessarily the best way of handling a timer, but you could certainly use them to do that. I'd be surprised if there wasn't a you definitely want it happening. So coroutine is effectively a thread. So you definitely want it happening in the background so it's not interfering with the rest of your game. It looks like what they were doing with the delta time was at the update level where they just kept checking delta time. And as soon as something had counted down to 0, that was the end of your timer. That's probably the cleanest way of doing it. Because that means everybody would have the same performance. You might be subtracting, well, roughly the same performance. You might be subtracting from your countdown more often on a faster performance graphics card, but time is still time. So you would just be getting a change in time that was smaller each time. All right, so in any case, that shouldn't have been too bad. Okay, so questions, comments, concerns, bribes. Everybody understand what's going down with the exam for next week? It might be up today, so you can take it whenever you want, but I promise you it'll be up by Monday morning, and then you can just do it anytime during the week, but it has to be done in one sitting. Cool. All right. I will see everybody probably next semester or around the summer if you're in town.